Okay, so now we'll move to the next part of the lesson, which is we are going to find other measures of location, in the sense the quartiles. We are mainly going to learn how to find quartiles for continuous data. Now in the previous part, we learned how to find these measures of locations for discrete data. So I gave you the rule and we did some examples by using these rules. So now it's time to use these measures of location to find, it's time to use these, to find the measures of location for continuous data. Okay, so look at this. When data are presented in a grouped frequency table, okay, when data are presented in a grouped frequency table, you can use a technique called interpolation to estimate the median, quartiles, and percentiles. When you use interpolation, you are assuming that the data values are evenly distributed within each class. Okay, let me explain to you what it means. So basically, what we are doing here is, the first thing is you need to realize how do you identify continuous data. What is the main way we identify continuous data? Now you can see in the example they have given over here, just look at the way they have given the X values. In the previous questions we did, you saw even in the group, in the frequency tables, the X value was a single digit, right? Did you have a range like this? You saw in the questions we did, the X values were single digit. So that is why we were able to clearly identify that they were what data? They were discrete data. So clearly these kinds of data, when you have a single value on top here, even in a frequency table, it's discrete data. But over here, I think you can clearly see we have grouped frequency table. So these are called grouped frequency table because you have groups at the top. So a group frequency table, the moment you set your eyes on it, you must immediately understand that this represents what data? A group frequency table means this represents continuous data. Okay, it represents continuous data. Why? Because for example, here the time spent on the internet in minutes, they have given between 30 to 31. There are two students, two people. Okay, so if there are two people, the thing with this these kinds of tables are, now you have two students who spend between 30 to 31 minutes, and in continuous data you can take any value within this given range, isn't it? So these two students could take any amount of minutes in between this given range. You can get many decimals in between this, right? Any value within this given range is possible. It's not, are we just the 30 to 31? Does it mean only the 30 to 31 integer? Does it mean only the 30 to 31 integer? No, continuous means you can break this down further. 30.1, 30.1 minutes, 30.5 minutes. You could break it down. Okay, so continuous means you can take any value within this given range. It can be decimals. Okay, so that's why. So here between 32 to 33 minutes, there were 25 students who took between 32 to 33 minutes. Are you following me? Which means these 12. But do we know the individual time taken by any of these people? Do I know like the individually this person took like the exact amount of time that any of them took? Do we know the exact amount of time that any of them actually took? The exact amount of time? No, I just have it in a range. We really don't know the exact amount of time that anyone took here. Okay, so so in this case, now here there are 25 people who took between 32 to 33 minutes. So it could be any value between 32 to 33 because time is continuous and you can break it. You can break it into seconds. So because of that, you can see in this case, you immediately need to identify this is continuous data. To find the quartiles and the measures of locations, you must use interpolation. Okay, so let's see how we apply interpolation. Okay, so in interpolation, the first thing to do when you're using interpolation is you must check for the boundaries. Do you recall how we checked on the boundaries? So checking on the boundaries, I think we did that in the previous exercises where we checked the places where the groups end and where it starts. So I think you can see over here. So let's check on this example. So you can see here, now this group, it starts at 30. It ends at 31. And you can see here the next group starts at 32, ends at 33. Do you recall? Do you see what's happening here? So you can see that there is what in continuous data, you need to realize there should not be gaps. There should not be gaps. So you can see here there is a clear gap in between these two values. So what's the first thing you should do? The first thing in these kinds of sums is that we must have the corrected boundaries. Okay, so let's make the corrected boundaries for this example and like just shall we go for the question in the book? Maybe we'll try a question. Let's try something like question number 4. Let's make a table. So first thing is we have to make the corrected boundaries. Shall we make the corrected boundaries? Okay, so we'll make the new table again. Let's quickly construct the table again. Okay, so weight, the weight of cow. So they have said here the weights of 31 cows were recorded to the nearest kilogram. The weights are shown in the table. Find an estimate for the median weight. So let's get the weight quickly. How do you get the corrected boundaries? How do you get the corrected boundaries? Do you recall what we did in the previous day? What did we do? So we have to get, you do need to remember, we took the midpoints, right? So we took the midpoint. So what are the corrected boundaries here? 349, 350. We do not work with that. So this should be 349.5. Do you recall? 349.5. You take the mid value of these two figures. 349, 350. So the middle of both of these figures, 349.5 is the corrected boundary. Okay, so if the boundaries need to be corrected, you have to correct the boundary. Okay, so all of these boundaries, first thing is you must correct them. Okay, so this is 299.5 to 349.5. Shall I just correct it quickly? Let's do it fast. Let's make the table quickly. Okay, so you can see here I have constructed a corrected class boundary table along with the frequency, and I also wanted the cumulative frequency. So I have constructed a completely new table. Okay, so they say here the question is the weights of 31 cows were recorded to the nearest kilogram. The weights are shown in the table. Find an estimate of the median weight is what they wanted to do. First thing we realize is that this is continuous data because I can see the data is in groups. It's continuous data. Okay, so and the next thing, the first in continuous data, the first thing we do is we have to check whether the class boundaries are corrected or not, which means whether they continue, whether they are whether the class boundaries continue without any gaps. You can see here the class boundaries have gaps. So when the class boundaries contain gaps, we need to take the halfway value between the gaps. So you can see here, I have taken the halfway values between gaps and I have fixed the correct table. Now let's go for the cumulative frequency. So first one, cumulative frequency, you add the frequencies, right? 3 plus 6, that's 9. 9 plus 10, that's 19. 19 plus 7 is 26. 26 plus 5, 31. So that is the cumulative frequency. Okay. Okay, so now we are ready to apply interpolation to find the median. Okay, so look at the way we apply interpolation. The first thing is to find the median. Okay, to find the median or the second quartile, isn't it? What was the formula we learned under discrete data? The formula I gave to you was n over 2, right? So the formulas are actually not going to change. Okay, so basically median, Q1, Q2, Q3, those formulas we had n over 2, n over 4, 3n over 4. These formulas are not going to change. Okay, the formulas are not going to change, but what we are going to do with the answer of the formula will be completely different in continuous data. So Q2 is n divided by 2. Okay, so now the first thing is what is n? As I told you in the previous part, always n is the total frequency. Okay, always n is the total frequency. So what was our total frequency here? You can see in the cumulative frequency table, we can clearly see total frequency is 31. Okay, so 31 divided by 2. Okay, so what is 31 divided by 2? 31 divided by 2, we get 15.5, right? We get 15.5. Okay. Okay, now the thing is, unlike in discrete data, we are not going to go to round up or we are not going to do anything to this decimal. We are going to leave it as it is because I actually want to see where the 15.5 term, where this particular term is 15 and a half. Okay, so the median is exactly in the 15.5%, because the thing is when it came to discrete data, it is not, we don't get these half positions. We don't get these middle decimal positions because we have exact, what do you call, we have exact terms. But when it comes to continuous data, you know, you can get any decimal value as well, right? You can get any number within the range. So because of that, when you get these kinds of decimal answers, we are not going to round up. Okay, so we are not going to round up, leave it as it is. Leave it as it is, and I'm going to find where this, where this 15.5, the position, where it is. Okay, let's see how it's done. So you can, I'll just show you a basic method that they follow in the book. You can also, you know, do this in a creative way. Okay, so what's happening here is the Q2, your Q2, the median, is at the position, is at the 15.5 position. Okay, now when it comes to 15.5, you do realize that that position is actually where? Now you can see that position is coming in between which interval, isn't it? Because you know this is the Q. You can check the position by checking the cumulative frequencies. So when you check the cumulative frequency, 15.5, 3 has not passed it, 9 has not passed it, but you can see 19 is the first cumulative frequency to pass 15.5. What does that tell you? It tells you your median group. Do you see? The median group is 399.5 to 449.5. Are you guys with me? This is the median group. This is the median group because the median is actually lying in between this interval. The median is actually lying in this particular interval. But now I'm not just satisfied with the median class. Okay, we are not just satisfied with the median class, but I want the exact pinpoint position of the median. Like if it is in between this class, then where in between this class? I want the exact position. So to do that, what did we find out now? We found that the Q2, the 15.5 position, by checking the cumulative frequency, it is in between 399.5 to 449.5. So I'll first mark that. What is it? My median, my Q2 is between 399.5 to 449.5. Do you follow me? Okay, so this Q2 is in between these two values, somewhere in between. It doesn't have to be exactly in the middle, but it is going to be somewhere in between. Now, how do I pinpoint the exact value of Q2? I know Q2 is something in between these two. How do I get the exact position? To do that, we are going to use the help of the cumulative frequencies. Now, what 15.5 cumulative frequency is in between what cumulative frequencies here? You can see here the cumulative frequency that is lower than 15.5 is 9, right? Do you see that is the place where the 399.5 term where it ends? So over here, you will mark the cumulative frequency as 9. Are you guys with me? 15.5, the cumulative frequency that is lower than 15.5 is 9 from the table. And the other one which passes 15.5 and which corresponds to 449.5 is 19. Do you see this? So when you do this interpolation, you kind of like draw this line. At the top, you mark the class boundaries, the respective class boundaries. And at the bottom, you mark the cumulative frequencies. At the bottom, you mark the cumulative frequencies. Okay, so you mark like this. And now all you have to do is you have to divide this interval. Now you can see here, there's a gap between 9 to 15.5 and 15.5 19, isn't it? So the same gap which you have at the denominator at the bottom here, at this bottom, you must try to divide the top one also by keeping the same ratio. You have to try to replicate the ratio at the bottom to the top so that Q2 will follow the same ratio that the cumulative frequencies are following. That's all you have to do. Okay, that's all you have to do. Okay, so now let's carry out the interpolation. The first thing, I think when we do a few more sums with the interpolation, this will go into your head, but let's go ahead with the first one and let's practice a few and then it should be good. Okay, look, now how am I going to replicate the bottom ratio at the top? Okay, that's the question. So see how it's done. So it's basically done by taking the difference. Now the top ratio, look at this, I will take Q2 minus 399.5. So Q2 minus 399.5 gives me this gap over here, right? So this gap over here should correspond, whatever the gap you have over here, the ratio should correspond to the gap at the bottom, which is how much? 15.5 minus 9. Okay, I'm taking these two gaps and I'm making them, and I'm taking the ratio of the gaps. That ratio must be equal to, okay, or else let me take it like this. Wait, let me take it like this. We'll take it like this. Okay, I'm going to take Q2 minus 399.5, this gap, and I'll take the larger gap at the top. Okay, first let's take the top numbers and take the gaps at the top. Q2 minus 399.5 is the gap over here, and then 449.5 minus 399.5 is the gap over here, right? So these two gaps. This particular, the gap ratio must be equal to what? On the other side at the bottom, look at this. So at the top, you took Q2 minus 399.5. So over on the other side of the equal mark, take the corresponding gap ratio. This should be equal to 15.5 minus 9. Do you see these two? I'm trying to say that these gap ratios are equal 15.5 minus 9 over what should be the other one. Now for the top side, I took 449.5 minus 399.5. So corresponding to that, if I take it from the bottom, it should be 19 minus 9. Guys, what I'm taking here is I'm taking the gaps and I'm trying to get I'm taking the ratios between gaps and I'm making it equal. So what it does is it will give you the position of Q2, just the position of Q2 such that it falls, the gaps will be, I mean, whatever the ratio you have at the bottom, you will be able to replicate the same ratio at the top. Okay, you don't need to worry about this, the ratio, how it replicates. All you have to do is to simply apply this equation. If you're finding it difficult, just simply apply this equation. What did I do? I took the top gap, Q2 minus the lower boundary, and then the upper boundary minus lower boundary. Okay, equal to, take the frequencies. Next, at the bottom, we have the frequency. So 15.5, you subtract with 9 over the larger gap, 19 minus 9. You can just follow this. If you're finding it, all the other stuff that I'm saying difficult, that's perfectly fine. Just go through this, go through these steps. All you have to do is to be able to follow and go through these steps. Then you can apply linear interpolation. Okay, so now all you have to do here is what? Make Q to the subject. Make Q to the subject. So Q2 minus 399.5 over 449.5. Let's subtract actually. So 449.5 minus 399.5 is 50. Equal on the other side. Let's type this whole gap. 15.5 minus 9 over 19 minus 9. So this is 13 over 20. Do you see? I have showed you in the cal. So this gives me 13 over 20 in the cal. Okay. And now it's time to cross multiply, make Q2 the subject. Okay, so Q2 minus 399.5 equals 13 over 20. The 50 will go to the other side as a multiplication times 50. Okay, and then Q2 equals 13 over 20 times 50 plus 399.5. Okay, so now it's a matter of typing everything in the cal to actually get the answer. So 13 over 20 into 50 plus 399.5. So answer is 432. So Q2 answer. Q2, the median weight. Actually, we were trying to find the median weight, right? So this is the weight in kilogram. So median weight is 432 kilograms. So this is how you find the weight in interpolation. So don't worry if this is difficult. Let's do a few more sums to actually practice with this. Okay, so we'll try a few more. Let's try to practice this. Okay, it needs to be practiced. Part B. They say find the lower quartile Q1. So find the lower quartile Q1. How do we find the lower quartile? Let me do it part B over here. Okay, lower quartile. So when it comes to the lower quartile Q1, I told you the formulas we use, that it doesn't change. It's just the application that will change. So Q1 formula is n divided by 4. Okay, that is the formula we use for Q1, n divided by 4. How much is n? N is the total frequency. Total frequency is over here, as you can see. Total frequency is 31. 31 divided by 4. So you will divide 31 by 4 and we will get a decimal answer. What is it? 31 divided by 4 and I get the answer 7.75. 7.75. So this is the position. This is the position that I find the Q1. Okay, so now when it comes, you know you are dealing with continuous data now. You will not be rounding it up. You will not be doing any of that sort of thing. What you'll be doing now is we will be drawing, let's draw this line. We are going to apply linear interpolation. We are going to apply linear interpolation. So I know Q1, we'll mark Q1 at the top in the middle, mark Q1 at the top. And at the bottom, you mark the corresponding cumulative frequency. Q1 is in the 7.75th position. The reason I'm saying it's cumulative frequency is because cumulative frequencies give the positions. So 7.75, Q1 is in the 7.75th position when data is arranged in ascending order. Okay, right. Now what I want to do is I want to see the first quartile, the data group where the first quartile falls in. So that also we find it by using the cumulative frequency. So go to the cumulative frequency and what do you see here? Cumulative frequency, the first one is 3. Does it cover until 7.75? No. Next one, it's 9. So you can see 9 passes 7.75, which means what? Which means your Q1 is a value, the Q1 value is falling in the range between 349.5 to 399.5. Okay, so your Q1 value falls within the range 349.5 to 399.5. How did I find it? Because of the 7.75, I checked the cumulative frequency at 7.75. The first cumulative frequency that surpassed it is this 9, which is the second group. And for the second group, the weight classes are 349.5, 349.5 to 399.5. Okay, are you guys with me? And then I told you what's the next thing you should do. I told you to use the cumulative frequency that is lower than this value for the bottom cumulative frequency and the higher one. So from the table, take it from the table. From the table, the cumulative frequency lower than 7.75 is 3. And the cumulative frequency greater than 7.75 is 9. So that's it. Now this is the diagram that you need to draw, the first thing. So draw this diagram first and then let's go to compare the ratios. Okay, so now let's go for the ratio. So how did I take the ratio? I showed you the way to get it in the previous one. Q1 minus 349.5. Take the gap. I'm going to take this gap over. Let's take the larger gap. Actually, this gap, you can take it any way you want, to be honest. Okay, so you could take the next gap as 399.5 minus Q1. But let's go for the one where we don't have too much of unknown terms. So let's go in the easy way. What is it? Q1 minus 349.5. Okay, the other one is 399.5 minus 349.5 equals, apply the same, replicate the same ratio to the other side. What do you get here? 7.75 minus 3 divided by over 9 minus 3. So you can see I'm taking this ratio at the bottom over the, so I'm just basically taking the two ratios. I'm equating the ratios on either side. Okay, so now let's type this Q1 minus 349.5 over 399.5 minus 349.5. How much is it? 50, right? 50. And give this ratio. 7.75. Okay, so over here on the other side, I have 7.75 minus 3 over 9 minus 3. So it's 19 over 24, right? The ratio is 19 over 24. So basically, I'm trying to replicate this ratio on the other side. So I'm trying to replicate the ratio, the bottom ratio at the top. And I want to find the Q1 value who is capable of doing that. Okay, so what do I get here? Q1 minus 349.5. 50 division will go to the other side as a multiplication. Then you get here Q1 equals 19 over 24 times 50 plus 349.5. So type this in the calculator to get your Q1. 19 over 24 times 50 plus 349.5. And we get the answer here, 389.083. So let's get it to the nearest kilogram. Okay. So Q1 to the nearest kilogram, 389 kilograms. So this is the answer correct given to the nearest kilogram. Okay, then the next one, Q3. In part C, they want you to find the upper quartile. Upper quartile Q3. Shall we do that as well? Upper quartile Q3. How do we get the upper quartile? Q3 is 3n over 4. So which is 3 times 95 divided by 4. How much is it? 3 times 95 divided by 4 is 71.25. Guys, is that okay? 71.25. So no rounding offs here. We will directly be using the value. So let's get the answer. Sorry, n value, that's not 95, right? Total frequency is 31. Sorry. So what is the answer here? 3 times 31. Divide by 4. Answer is 23.25. Okay, so now let's go for the interpolation. So you get here Q3 is 23.25, the position. Now let's find the interval. Let's find the interval that Q3 lies in. So 23.25, let's try to find the value 23.25 from the cumulative frequencies. So 3 is lower than that, 9 cumulative frequency is lower than that, 19 is lower than 23.25. The first cumulative frequency, 26, is the first one to pass 23.25. Do you see 26 is the first cumulative frequency to pass 23.25. Therefore, the Q3 range, the Q3 value is in between 449.5 to 499.5. Okay, so your Q3 value is going to be between 449.5 on top. Okay, 449.5 to 499.5. So Q3 is going to be in between that. 23.25 is the cumulative frequency. So now I told you what should you do. Use the cumulative frequency lower than 23.25 at the bottom and the cumulative frequency higher than 23.25 at the top. So what is it? The lower than 23.25, it's 19. Higher than 23.25, it's 26. So over here, this is 19 and it is 26. Okay. Now let's go for the, after you're done with this diagram, you can now easily go for the replication, go for the interpolation. So let's go for the interpolation. Q3 minus 449.5 divide by 23.25 minus 19 equals 26 minus 23.25 over, sorry, 23.25, I'm sorry, 23.25. Okay, I'm really sorry. I'm doing this wrong, right? I'm doing this completely wrong. Q3 minus 449.5 subtracted by 499.5 minus 449.5 equals 23.25 minus 19 over 26 minus 19. So I took the gaps correctly now, right? This gap on this and then the other one, 23.25 over 19 minus 20 over 26 minus 19. Okay, so Q3 minus 449.5 over, this is a 50, right? On the other side, what do we get? 23.25 minus 19 over 26 minus 19, and I get the ratio 17 over 28. Okay, and then let's input the values. Q3 equals, shall I do it immediately now? 17 over 28, the 50 goes as a multiplication and the 449.5 goes as addition. I did this immediately. And I get here 17 over 28 into 50 plus 449.5. So the answer I get is 479.857, which means very round to the nearest kilogram. It's 480 kilograms. So answer is 480 kilograms. Okay. Okay, then moving on to part D, interpret the meaning of the value you have found for the upper quartile in part C. So upper quartile answer for part C, we found the answer as 480 kilograms, isn't it? Part C answer Q3 is 480 kilograms. So how do you interpret the meaning of it? The meaning, right? Like they want you to say what it means in the context of the question. The context of the question, the question speaks about the weights of cows to the nearest kilogram. So you have the weights of cows. So how does this 480 kilogram relate to the context of the weight of the cow? Okay, so how does it work? So I have showed you when it comes to this diagram. So you can see the upper quartile Q3. The upper quartile Q3 is covers 75% of data. So 75% of the data values are below the upper quartile. 25% of the data values are above the upper quartile. So this 480 kilogram is the upper quartile value. The 480 kilogram weight is the upper quartile value, which means what? 75% of the weights, 75% of the weights that are distributed in that particular table is lower than this 480 kilogram. Okay. So you could say 75% of the weights are lower than 480, or you could say 25% of the weights are more than or exceed 480. So I will go with the 75%, which is the more widely used term when it comes to the upper quartile. So below the upper quartile, you have 75% of the data. So you can say 75% of cows weigh less than 480 kilogram, which is the Q3. That is the Q3 value. So 75% of the cows are going to weigh less than that. Okay. Okay, so you can see the table that I have built over here. So we don't need to go for any boundary corrections. There are no gaps. So I have written the boundaries over here. The first one is to estimate the mean time spent waiting. So mean time, you know how to find the mean when it comes to a frequency table. Total effect, sigma fx over sigma f, isn't it? So we learn the equation. So you can see I have built my table accordingly. Frequency, the time, the frequency, cumulative frequency is definitely required when we are going to find these quartiles and percentiles. Mid value and fx are the reason I included these two columns into my table is because we are trying to find the mean. For mean, we need the midpoint, isn't it? And the fx we need it. So frequency values are given to me 6, 10, 18, 13, 2. Cumulative frequencies when you add these stuff, right? So how much is it? 6, 10 plus 6 is 16. The next one, 34, 16 plus 18, 34 plus 13, 47, 47 plus 2, 49. Okay. Yeah. Okay. Then the mid value. So how do you get the mid value of the class interval? You get the mid value by adding these two figures and dividing by 2. So 20 plus 30 divide by 2. 20 plus 30 when you add and divide by 2, it's simply 25. You can see it's basically the middle of 20 and 30. 30 plus 40, mid value is 35. 30 plus 40 divide by 2. Next one, 45, 55 and 65. Yes. And then the fx value. So fx value is when you multiply the frequency with the midpoint. Remember, you multiply the frequency with the midpoint. So 6 into 25 is 150. 10 into 3, 35, 350. Remember, you multiply the frequency with the mid value. Okay, not the cumulative. So fx. 18 into 45 is 810. 13 into 55, 715. 2 into 65 is 130. Is that okay? Check these figures and okay, and then the total effect. So basically, the mean is sigma fx. So sigma fx means you add all these figures and get the total. So how much is sigma fx? The total of the fx values, 2155. 2155. Total frequency should be 49, right? Because cumulative frequency is here the final figure of CF is 49. It means the total frequency should be 49. So now I can go to find the mean, part A. So mean is gonna be sigma fx over sigma f. This is formula we learned it the previous day. Sigma fx is 2155. Right, 2155 over Sigma f. So sigma f is 49. 2155 divided by 49 is 43.98. Yeah, so for it goes on like this. Let's give it to 3SF. So when you give it to 3SF, it becomes 43.0, right? 43.0 minutes. And you can give in bracket you have corrected this to 3SF. 43.9 corrected to 3SF, 44.0, yes. 44.0 minutes corrected to 3SF. Okay, part B, they ask us to calculate the 65th percentile. So how do we calculate the 65th percentile? Now, I think I have given you a clear note about the quartiles, but not for the percentiles. So anyway, let me tell you now, percentiles means it's percentiles divide the data into 100 parts. I will give you a note at the end of the question, a clear note on percentiles. So percentiles will normally divide the data into 100 parts. Quartiles divide the data into 4. Percentiles divide the data into 100. So 65th percentile is basically 65% of your of the data. So basically here part B, when they want the 65th percentile, okay, 65th percentile, we write it like this. 65th percentile is also written as, write this down, P35. Write this down, so this is quite new to you. P65. 65th percentile, also known as P65, is 65%. It's 65%, 65 over 100 of the N. N means the total frequency. Okay, 65% of your N value. Are you guys with me? So now let's use the value 65%, 65 over 100 into N. N is total frequency is 49. So let's take 65% of 49. How much is it? 65% of 49. Is it an exact decimal, or do you, I think you get a decimal, but is it an exact decimal or does it go forward? 65 over 100 into 49. It's an exact decimal. 31.85 is because the thing is now we are working with what data? We are working with continuous data, isn't it? So then I want the full figure, 31.85. So this is the position. So I have to take this the position, 31.85th position. So no rounding offs. You should not delete any of the decimals because we are working with continuous data. So I want the 31.85th position. So how do I get the position? We get the position by using the cumulative frequency. The cumulative frequency comes handy, is useful to identify the group, with which this particular person lies in. So 31.85 data point, 31.85. So it's not under 16, not under 16, but it's under 34. That's the first cumulative frequency you get, which is passing 31.85. Therefore, your 65th percentile is between 40 and 50. Okay, so it comes between 40 and 50. So now you draw this line. Let's draw this line and mark this P65. P65 is 31.85. So P65 is between 40 and 50. And what are the two cumulative frequencies in between? So 31.85. Look at the cumulative frequency column. 31.85 is between 16 and 34, right? It's in between 16 and 34. It's in between 16 and 34. Okay. Right. So now it's time to apply what? So you are working with this continuous data. You must apply linear interpolation. Okay, so we get here P65 minus 40 over 50 minus 40 equals 31.85 minus 16 over 34 minus 16. What do we get here? P65 minus 40, 50 minus 40 is 10. 31.85. minus 16 over 34 minus 16. And I get 317 over 360. Is that okay? I get 317 over 360. Okay. And then let's make P65 the 65th percentile the subject. 317 over 360. Multiply by 10 and you add 40. So I get here 317 over 360 into 10. You add 40. What do we get? 48.805, right? I get 48.80. So correct it to 3SF, 48.8. This is what are we measuring? Time? Yeah, it's time in minutes, right? Yeah, time waiting in minutes. 48.8 minutes is the 65th percentile corrected to 3SF. Okay. Okay, so the last part, the firm writes the following statement for an advertisement. Okay, only 10% of our customers have to wait longer than 56 minutes. By calculating a suitable percentile, comment on the validity of this claim. So, is this claim valid or not? So, what do they say in the advertisement? They say only 10% of their customers wait longer than 56 minutes. Okay, now you can see here in this table they have given you the waiting times. Okay, they have given you the waiting times, basically the amount of waiting times and the frequencies. So they are saying only 10% of their customers, only 10% of their customers will wait more than 56 minutes. So is this true? Is this true? So we need to check on this claim. Okay, so how do we do this? Okay, so now they are asking you by calculating a suitable percentile. Okay, you need to comment on the validity of the claim. How do we take the correct percentile? Now, when people see it only 10%, when you see the word 10%, immediately we feel like going for the P10. P10 means 10%. But remember, P10 covers only 10% of your data. P10 means now if I draw this line over here, let me draw this line. So this line represents your complete data set. Okay, bear with me. This line, let's say this is the lowest value. So this line, the starting point is the lowest value and this is the highest value. Okay. So, you know, when percentiles divide your data into how many parts? Percentiles divide your data into 100 parts. So then if you take P10, where do you find P10? So here in the middle, the median is there. So P10 should be somewhere over here, right? Like it divides it into 10 parts. So this is P10, where you find 10% of your data. So what they say here, this is the P10 part. So do you think what they say here matches with what you are taking? P10 is just this small portion of the data. They say only 10% of their customers waiting longer than. Now you need to realize this is these percentiles are the times. So whatever the time you have here, they are saying waiting longer means from that point you stay more than that amount, isn't it? So more than. So then I think you can see here 10% for P10 covers. So this is 10% of the people who stay less than this particular time. So for P10, let's say, let me just say that it is 25, I'm just assuming, okay? So which means you have like 10% of customers staying less than 25 minutes. So that's not what we want here. I hope you guys are getting what I'm saying. It's not P10 you require here. It is not P10 you require because they say they 10% of their customers wait longer than. They use the word they wait longer than, which means you need to find here which percentile. You have to go for the 90th percentile and then you find the people who wait longer than this given time. Okay, so P90, you have a certain time value that you get a time value for the 90th percentile. And then you can get the amount of customers who actually stay longer than that particular P90. Okay, so then we need to see whether that value is actually 10%. Okay, so what we'll do here is first let's calculate the 90th percentile. So how do you do this? By calculating a suitable percentile. So they're asking us to calculate. So what is the 90th percentile? So what is the 90th percentile? You can actually, you can actually like maybe directly see this as well. So 90th percentile is 65 over 100 into n, right? So the 90th percentile means n means, 90th percentile means 90%, 90 over 100. So 90th percentile is 90% of the n value. N value is 49. Guys, are you with me? The percentile equation is the percentage amount into our total frequency. So here it's 90% of our frequency. How much is it? 90% of the frequency is it an exact figure? 90% of 49, right? Yeah, it's an exact figure, 44.1. Okay, so then you can find P90 by doing interpolation as well, right? Okay, so okay, so the 90th percentile is in the question 44.1. Okay, so let's calculate the 90th percentile quickly. So what is the 90th percentile? 44.1. Okay, guys, just bear with me. I will explain to you in a moment exactly what's going on here. Okay, so just bear with me. Now, they say 10% of the customers wait longer than 56. Basically, all you have to do here is check on this value 56. You can see this star 56 is definitely between 50 and 60. All I have to do here is check whether this 56 is the 90th percentile, or that's what we need to do here. This 90th percentile, we need to check whether this value is 56 or not. If the 90th percentile is 56 minutes, then what they're saying is true. Okay, so they say 90th percent, they say only 10% of their customers wait longer than means this section. So when you wait longer than, that's this section, the one I'm coloring. So less than is the lower side, more than means the higher side. So only 10% of the customers wait more than means, so if there's 10% over here, okay, so their claim is that the 10% of the customers who wait, only 10% of their customers are waiting more than 56 minutes. So we need to check whether this at 10%, the highest 10%, is it at the 56 time mark? That's what we need to check. We need to check whether this value is 56 or not. Is it 56 or is it not 56? So we need to check on this. Is this true or not? Okay, so then is this 56 minutes or is it more than 56? Are they trying to, give it more than what it is? Okay, let's see. So use linear interpolation. Use linear interpolation quickly and let's check the true value. Let's check the true 90th percentile. Okay, so what is the true 90th percentile? So P90. So P90, the cumulative frequency is 44.1. So 90th percentile is in between where and where? 90th, 44.1. Go for the cumulative frequency 44.1. 44.1, you can see 6 is more, less than, 16 is less than 44.1. 34 is less than 44.1. 47. You can see 47 is the first cumulative frequency who passes. So definitely you can see it's between 50 and 60. Okay, so that should definitely come there between 50 and 60, and the cumulative frequency less than 44.1. The cumulative frequency less than 44.1, you have 34, and the other one who is passing 44.1 is 47. So here the cumulative frequencies are 34 and 47. Let's calculate the 90th percentile. So P90 minus 50 over 60 minus 50 equals 44.1 minus 34 divided by 47 minus 34. So P90 minus 50 over 60 minus 50 is 10. Get the answer. How much is it? 44.1 minus 34 over 47 minus 34. That is 101 over 130. Is it? 101 over 130. Okay, we'll check on that just to be safe. 44.1 minus 34 over 47 minus 34. So I get the answer, yeah, 101 over 130. So then let's make P90 the subject. P90 equals 101 over 130. You multiply by 10 and then the minus 50, you'll take it to the other side as plus 50. So give everything in the cal and let's get the real P90 value and see whether it matches to this 56 that they claim. Is this true? So 101 over 130 into 10 and you add 50. So is this correct? Let's check whether this is correct. So we get 57.76. Can you see the time in minutes? The 90th percentile is 57.8 minutes, corrected to 3 years. 57.8 minutes. So guys, what do you have to say about this, their claim? Are these people being truthful about the claim that they are giving? They say only the 10% of the customers who wait the longest are waiting only longer than 56 minutes. But is that the true value? The true 90th percentile is 57.8 minutes. So actually, they are giving a lower value than the real value. You see, the real 90th percentile value is 57.8 minutes. So you have 10% of people who wait more than 57.8. So if you take 56 minutes, it is lower than. It is actually lower than the 90th percentile, isn't it? Because your 90th percentile is 57.8. So this is not true. Do you get what I'm saying here? Okay, so just a quick explanation at the end. Now they say here only 10% of their customers wait longer than 56. Guys, the moment you see waiting longer than this 10% comes to the very end. If it comes to the very end, it's not P10, it's P90. So what is the claim here? The claim is the 90th percentile is 56 minutes. So this is the claim that they are doing, that they are giving. So we need to check the validity of this particular claim. Is this correct? Is the 90th percentile actually 56 minutes or is it more than that amount? Okay, so you can see here when we actually calculate the 90th percentile, when I actually calculate the 90th percentile by using linear interpolation, I get 57.8 minutes, so which is higher than the value that they are giving. So they have kind of like made it lower. Okay, but that's not the true value. So the real 90th percentile is 57.8. Okay, so is the so you can write here P90 is 57.8. So the value that they have claimed, the claim is true or not? The claim is false. Okay, so comment on the value. The claim is not valid. You can write here. May I give the claim? The claim is not valid. So what is that? On 10% of the customers wait actually what? 10% of their customers wait what? Wait longer than 10% of the customers will actually wait longer than 57.8 minutes, not 56 minutes. Okay. So 10, because the real 90th percentile is 57.8, 10% of their customers will wait longer than 57.8 minutes. Okay. So this is how the understanding. You need to clearly understand the claim that they are giving here. Okay, so then the last part of the lesson, I just want to give you a quick note on the percentiles. Let's finish it off. So when it comes to percentiles, okay, previously I found quartiles for discrete data. So percentiles, I'll be discussing it for both discrete and continuous. So if your data is discrete, okay, so if you have if you're trying to find percentiles for discrete data, okay, the first thing is anyway, say you're trying to find the X percentile. Okay, so like if you find the 10th percentile, I told you it's P10. If you're trying to find the 65th percentile, it was P65. Likewise, the X percentile. X percentile means the X could be the 10%, X could be the 20%. Okay, so X percentile equals, write down, X percentile PX equals X over 100. So X over 100 means the X%. X% of N, where N represents the total frequency or the total number of data points. Okay. And then if it's discrete data, again, you must apply the same theories that you used previously. Do you remember the same theories that you used previously? So if it is discrete data, okay, so you can write this down. If this is a whole number, again, you can apply the same rule. If the answer is a whole number, Then you take the midpoint of this term and the term above. However, if your answer is a decimal figure, you round the number up. Okay, this is for discrete data. This is for discrete data. Guys, what we did previously, the question we did was we did with continuous data. Okay, I'm just giving you the quick note. What if you get percentiles for discrete data? Okay, so for discrete data, the percentiles, this is the way you follow. You use the same equation. So if it is 10%, then X is 10. And N is the total number of data points. And whatever the answer you get, if it's a whole number, you take the midpoint of that term and the term above. But if it is a decimal, you round the number up and pick the corresponding term. Okay. Let's go for a quick example. Okay, so I have given a quick example to just to quickly round this off because we did not do any question where we found the percentile for discrete data. So 80th percentile is P80. So now you can see the data set I have given to you here. The first thing when you work with discrete data is what? Make sure your data is arranged in ascending order. That is the first thing you do with discrete data. So in here, what do you see here? Data is, I think it's already arranged in ascending order, is it? Yes, the data is already arranged in ascending order. So P80 is 80% or 80 over 100 of how much? How many data points are we working with here? How many data points are we working with? 1, 2, 3, 4, 5, 6, 7, 8 times 2. There are 16 data points. Okay, so 80% of 16. Can I know the figure? What is the position? 80% of 16. 12.8. 80% of 16. 12.8. Okay, so you can see you get a decimal figure, 12.8%. So what was the rule? If you get a decimal, what was the rule? Now you can see I have given the rule here. Okay, if the answer is a decimal, round the number up. Up means you go always to the larger figure. So 12.8 in the larger number is 13th value. So 13th value, the 13th value should give you the 80th percentile. So 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th value. 9th, 10, 11, 12, 13. Can you see? So 13th value, 1025. So the 80th percentile is 1025. Do you follow me? Is this clear? Okay, so this is all you have to do. When the data is discrete, all you have to do is to simply follow the rules that you applied for quartiles, but the equation is different. That's all. Okay, so what about the percentiles when the data is continuous? The percentiles under continuous data? So percentiles, but what if your data is continuous? If the data is continuous, the X percentile is X over 100 into N. And there are no rounding offs. You will not do any rounding offs or anything like that. You will directly what? Take this value and apply. You will take this value and apply interpolation. You will take this value and apply interpolation. So we have done this in an example in the, I think over here, we did it, right? So we did an example where I applied interpolation to find the percentiles. Can you see? I did question number 5, right? So question number 5. So I applied linear interpolation to find the percentile. So this is when the data is continuous. Okay, so if the data is continuous, you will apply interpolation to find the percentile. But if the data is discrete, then you will apply this particular equation and go with these methods. If it's a whole number, you take the midpoint of that term and the term above. But if it's a decimal, you round the number up, pick the corresponding term and pick the percentile. Okay. So this is all you need to know about measures of location.